hope everybody's and you should have my voice. Am I right? Hope everything works fine. And I just managed the YouTube channel. And then to start, because I see most of the people from the Google Calendar have joined already. My name is Iman, as you might know, and شقایق انواع بود this workshop, and hope everybody well and follow the step workshop, have completed the Excel and have the requirement software as presented in the URL of the workshop. So if there is no question, I share my screen and that's how everybody has my voice or not. It's a question from so it's okay.
Hi everyone.
It's good.
That's great. Hi.
Hi there.
So let me share my screen and we go over one preliminary steps, and that would be opening my Rhino. One thing that I think everybody should follow in this workshop is that we will work with Rhino, but all the people should open their file like large object meter templates. The reason is that because our LCA software, energy analysis software, anything we use, our daylight engine that we use all work with metric units, so we should follow the metric units in our modeling. So if you're not familiar with Rhino and Grasshopper, here is the Rhino surface. On a standard tab, we have Grasshopper icon, and also you could type Grasshopper and it will open up the Grasshopper window. The most important thing is that you should have a tab here called Ladybug. And if you drag and drop one icon in here, your icons shouldn't be, your components shouldn't be red. So to be more specific, it's better to check one other thing, and that would be, let me stack it here. In we use different software in this workshop, and in a tab here called Honeybee, under Visualize tab, we have two components, HB check version it would take a while because it checks the version of the software that is installed, and HB config. So why these components are important for us? We use Ladybug Tools version 1.6, so all of you should have this version. Let me go and grab a panel here. and check this with me. You should have Ladybug 1.6. You should have Python 3.7 or higher. My main concern are these three outputs. You should have installed Radiance for this workshop. 5.4, Open Studio, and Energy Plus. I know some of you might not have this software, Open Studio and Energy Plus, mainly used for our energy analysis, and we use Radiance for our daylight simulation. So if you don't have it, don't get worried. There's a link that describes the Ladybug Tools Grasshopper plugin installation step by step. Some of you may follow the Windows installation, but here we have optional installation which talk about the Ladybug tools, which talk about Radiance, Open Studio, and Urban Opt. We don't use Urban Opt, but these two are necessary. But there is one other important thing. Here we have a check compatibility matrix. What we use in this workshop is 1.6, this Python, this Radiance, and if you want to follow me, let me copy these links in the chat. Here is the link to the GitHub. Here's a link to compatibility matrix. So let me click, for example, on Radiance 5.4. As you might know, it's a GitHub page. So we scroll down at the end of the page, we have assets. And you should have downloaded the Windows exe file here. Same with Open Studio and others. Let me the chat if no, there's no need for installing anything. One thing to consider, if you're having the Ladybug tools and I don't know, the version 1.5 or 1.4, that works fine. But if you have legacy version, they work together and no conflict would have happened. On any cases you want to uninstall your Ladybug tools plugin, it's not that much easy. And let me show you the process. At first, you should have downloaded the Ladybug Tools plugin from Food for Rhino. Here is the link into Food for Rhino, but let me refresh it maybe. Here it is. If you download it and extract it on your computer, you came up with a folder like this, which is about the Ladybug Tools 1.6. And in Ladybug Tools 1.6, you have the uninstaller. So what we do is that we open up our Rhino and Grasshopper. Let me disable the preview pane. And you drag and drop the uninstaller on your canvas. If you set this to true, it will totally and completely uninstall the Ladybug tools, and you could reinstall it. Don't go any other way, like going to, I don't know, a special for the user object. That would mess up with your installation. So, how many of you have the Radiance, Open Studio, and Energy Plus installed and LVT also installed. If anything was unclear, just let me know and I repeat it or rephrase it so everybody get involved. Okay, I will install bifocal right now. So let's go to the here and bifocal. So here is bifocal. What bifocal do is, there is a white pop-up above my components. If you type it exactly as written there, for example, here I have Ladybug download weather. If I type Ladybug download, if you type it exactly like there, the component will came and you could just put it on canvas and go on. From the Excel Google Sheet, I know most of you are familiar with Grasshopper. Some of you are familiar with Python. So I think could go above these essential steps, but the basic one and primary, and dive a little bit deeper into the Ladybug tools and checking gradients. Okay, great. And okay, let's go. For very early step, let me open up a new canvas. We have Ladybug here. Oh, I missed it. My Ladybug here. We have different ribbon here from importing, analyzing data, visualizing data, analyze geometry, and etc. And what we do is we go step by step on this direction. Here I start with the first component, Ladybug download weather data, and I want weather URL from me. Where could I find weather URL? Here on Ladybug EPW map. If I bring a toggle, a Boolean toggle here and connect it to EPW map and put it on a true, it will open up a window for me called Ladybug Tools EPW map. Each dot here represents a weather station, and here you could see the different source of weather stations. And for example, I could go to Brazil and just click here, copy link to clipboard. That's it. I close here and bring up my panel. And paste the link here, connect it to weather URL file. It will automatically download the EPW file for us. So here I have my EPW file, and I click here, Ladybug or EPW, And for example, we have dry bulb temperature and we want to visualize it hourly. So I go to second tab, visualize data, hourly plot, and dry bulb temperature. Let me stack it here and go top. And we have the dry bulb temperature of, I don't know, the city, Canfresa, if I'm right, from the Brazil. And our source is Ian Met. To make sure everybody is following, I think it's very, very necessary step here that all people should have an hourly plot of dry bulb temperature from the anywhere, any city they like. If you have it, you could go on and dive a little bit more deep. I could stop sharing my screen, and if anybody has any problem, we could maybe check there. If not, we could go maybe. Okay, great. What about there? No answers makes me worried. Okay. Don't get it. We started from right now. Maybe you started 30 minutes earlier so that everybody, yeah, of course. Here again, I share my screen and we have, it wants the components. I also could save the grasshopper file under here, and day one part. And maybe send it in a chat. Here it is, and oops, I think I've saved it here. Let me save it again. Day one and part one. And here it is, and send. About asking about what version of OpenStudio should be installed, don't check based on my screen. The main source to check is here. If you have the Ladybugs 1.6, you should have Radiance 5.4, OpenStudio 3.5, and the rest goes on. And one thing,
sorry, could you please share the link with our share the link up? Yeah. Okay, thank you.
Chat, and again, I'm again sending the link here. Let me so if everything is all right, maybe we could go live or not. I don't know. Great. And so I've checked right now and see the YouTube work also works fine. And so let's start by one question. Feel free to install the software. I know it may take some time. I just want to share with you one other cool website, maybe. And that would be here we have a specific site called Weather Spark, and I will send the links to you in chat again. And here it is. We have different range of data here, from the temperature, we have the hourly plots, everything, and also we could have a map here to find exactly the same map like we have in Ladybug tools and get all these data. So why did we use the Ladybug tools? I know you're familiar with lots of sites similar to this, like CB Climate Tool or Climate Plus by MIT, which work exactly in the same way. I don't know, you type the name of the city do you like and choose the location. For example, here I type London. London. You see different, we have different London, and here I went to JBR. And in outdoor, it will also show me this past temperature, wind, etc. And the true question remains that why should we use ladybug tools that we have such a cool software here? I just wait some minutes and also share this link with you. I will share all the links in Discord. Feel free, no rush to anything. Okay, maybe refresh a page. And go to temperature. And maybe just move it. Do anybody feel or have the same experience as I have with the Climate Plus with MIT? Okay, let's bring it up. I should have waited. Here exactly you have the temperature, you have the degree days, and probably the radiation map, and radiation in different phases, and an LMR, sun pass, everything. Actually, to be honest, if you go to visualize that, that's all you could get exactly from this site and exact from here. The most important thing here is that now we have access to data. So by access to data, if you go to Ladybug, here we have deconstruct data. I bring it on my screen and plug it into dry bulb temperature. It has two headers. I bring up my panel. Header 1 is explaining everything to me. It's dry bulb temperature from 1st of January until the end of December, from the hour 0 to 23 at the time step of 1 hour, location, city, country, time zone, and etc. And here we have the value for each single hour, which means there are 8,760 hours because the list starts from 0. And having access to this information could lead us to more decision-informed results. To show you one example of what I mean by decision-informed results, here, if I make the model layer here and check it out, all the model come from year 2009, and we are now on 2020. If you find some file, and some files even from 2023. So is this data valid? So let's go a little bit deeper. Maybe I could have go to one other software. There's a specific site called Climate One Building, and here I'm in a specific location. So let me go here to see the main website, and then we go on, and also sending the link again in a chat. So you have the different region with numbers, and let you decide which region you want to go. Somebody drop it on the chat. Do anybody have my voice? Just choose any region from here, region 1 to 7, and we go deeper to the country, to the states, and go on. So from 1 to 7, just pick a random number, maybe. Okay. And I don't know, I just click. Okay, fun thing to know. I don't know the Palestine has a weather file. It's funny. I to Palestine. And here you could see different weather data that we have here from a different time zone and different location. Let us go to maybe more vulnerable location. I go to Germany. And maybe here go to Berlin. And you see from the city of Berlin, we have the data from 2004 to 2018. We have data from 2007 to 2000 to 2021. And I copied this link address and paste it on my canvas here. It can download everything. And in order for us to remember, we copy paste each to bring up the script component in Grasshopper and type a year near it. And here it is, our script 2004 to 2008. And if you do the same, you came up with this result. Very funny result. It's like what the file you have that contain the environmental data came from different years, each month. And again, is trustable. So what I want to do is do one other specific thing. Here I Control C, go to edit, copy, and paste. And I'm going to bring the data from 2007 to 2021. And paste it here. Exact location, different time mapping. And type it here, 2007 to 2021. Everything works fine. Same location, everything. And maybe we could visualize this time the model year from here. And if you just click on a shift and wire it in, you have both together. For example, even in files, we have some similarities somehow on August, for example, or just, but I want to focus on more advanced solution. Here we have the dry bulb temperature of two same EPW file from the same location. Everything is the same. And we want to know how temperature is different from these two files. So what is I go to my Ladybug tools here and bring up the construct data again. We have two data. I want to minus the data from 2004 to 2018 from this file. So I bring up subtraction. I subtract this value by this value. And in the result, we have again an hourly data, exact 8,000 hour. To be more exact, 8,716 hours. But I could not visualize this data. If I bring my hourly temperature, it's need data. So what should I do? Here again, we have component called construct data, which get my, okay, if this one is the construct, let me delete it. And here I have Ladybug construct data. So at first, it said what's the data you have. It said maybe bring up my panels and type funny thing happened. I say my rhino and grasshopper, close it and probably open it again. There was something happened with clipboard that if I type anything, it wouldn't happen, at least show. So first thing first, let me delete these components and go back to Ladybug. And here we have Ladybug construct data, value here, and we need some header. For header, we should specify like what's our data type. A cool thing for Grasshopper to note, if something have underscore on its first part of the letter, it's necessary input. If it has underscore on both sides, it's optional. If it has underscore on the last part, it wouldn't show anything, but it would affect the results. So, for example, in data type, I could type temperature. One thing to note, if it's something like temp, it said it's wrong, and you should choose between these types. To be more exact, what I have here is temperature delta. One thing, how could we access this information? If you click on any Ladybug tools, it's open up a Python script editor. And in this Python script editor, we have different tabs and different data. And if you want to know where the component is, you could look for this and it would answer your result you have. So let me type again, temperature. I think the delta is with caps if okay, something maybe I type it wrong. Oh, I missed an E. temperature is okay. And here I connect it to header, and I connect it now to date. Let us see what have the result shown on over this result. So here, middle click and hide. We have up to minus and plus 17 degrees Celsius temperature difference between these 2 years, especially when on February and maybe on December. The rest, especially in July and August, we have no temperature difference at all. So let's put results more clearly. Here on extra tab, we have the legend parameter here. My ladybug legend parameter. Oh, I forgot this time to bring my bullet flow. We have ladybug legend parameter. I type from -20 to 20 and connect legend parameter to see the results. So here are results shown more clearly. And that's it. To be honest, I didn't expect this much of temperature difference between these two files. I just want to check the location. Berlin, Schoenfeld is exactly the same. So let me go full screen and maybe shall I tell whatever you want or think necessary?
Sir, could you please use bifocal? Yeah, bifocal again. Thank you. Sorry, you're muted.
Okay, I just tried to clean up the canvas so everybody could know bring what components and when. Is everything clear? Okay. If anybody reached a new result, I would love to see it and maybe share his or her screen with us. It would be nice to see others' results on different cities. Of course, I will share the GH file, but just to try out yourself, I think bring the component and maybe somehow try to work with them. or so what I do for better understanding, I file together and go to my Scribble. Here we have visualizing data, and here I do differential 10. I think I type something here, differential 10. I miss T, the type T. Okay. If everybody's good to go, maybe we could dive a little bit deeper. So who knows which temperature above we need? It's very generalistic, but with shading devices. Any guess? Maybe make a poll. Okay, we'll take lots of time to set up a poll. What they usually say is about around the temperature 18 to 20 above we need shade. But how could I visualize here on temperature we need shading? It's like we have could go to mass, and here we have greater or larger than. You know, this won't work. Why? Because we need Ladybug deconstruct data to have the data. Here we have the value larger than which temperature. I put it here, for example, 18. As a result, here if you could see, we have true and falses. There is one thing we could do here and bring up mass addition. What mass addition does is count every false 0, every true 1. So we need shading for about 1,500 hours from here, but in which time? So let's plot it out. Again, Ladybug, construct data. Here we have our value. We need to make a header. And okay, here I have my Ladybug construct header. I should specify the data type. And the problem that we have here, as let me just plug something like temp in and see what data type I could plug it in. What I have here is the value of 0 and 1. And here I don't see much. Of course, I could put anything like temperature here and have those 0 and 1. But we have something here called type, which is Ladybug data type. And here we could have different categories and units and etc. to make a specified data type. But I'll do it. It's just, it would take lots of time and we don't need it. We could use temperature delta as you have here. To have it as a header. But we know it's not a temperature delta type. So let's go to Ladybug hourly plot. And maybe hide these results. So what you see here is that it's somehow obvious that we don't need shading in winter months. And there's other thing, we don't need shading at night or early in the morning. Even the temperature is high, but there are no sun to use the shading. So making this general assumption that we need shading for 1,500 hours per year was wrong. So what could you do to eliminate the results, these parts and this part? Does anybody have a suggestion or maybe could bring up something? Okay, what would you do with radiation here? So let me work my way through the radiation. Of course, there are other methods that we could use. Again, I go to deconstruct data. And here I maybe use global horizontal radiation. And what it has different values from 0 . And when it's 0, it means that we don't have global radiation, okay? Again, my grasshopper just malfunctioned. Okay, save it again, close it, open it. I have two of them simultaneously opened. So let us first visualize the global horizontal radiation results. Okay. Let me check the chat. Here we could see the radiation that we get globally on a horizontal surface. I could write again a larger than. This time larger than 0. And maybe you could check out this value. So here we have something like, is sky have radiation? Is sun is in the sky or not? We could use very simple component here as with name gate and. What does gate and do? Is that, okay, if the temperature is larger than 18 and if the global horizontal radiation is larger than 0, then the result would be this. So let's mean and let us check how much different was it to our, just copy and paste it. It's like 200 hours was not necessary in this calculation out of these 1,500 hours. And of course, we could all deeper and said we need shading. Usually it's wrong because we have here is not radiation on a vertical surface which our window wall located, but we could put up something like 150 as a radiation and it would eliminate much more. So any questions so far with working data in Rhino, Grasshopper, and Ladybug? I will send the Discord link again. Okay, we do all the, so let me stop my screen and open up my Discord and maybe send the file on Discord for easier access. We know Dave, we actually, and Heliosa, I think. I think everybody could share the screen. Am I right? Oh, okay. I put it on all participants. So now I think everybody could share the screens. And maybe if anybody has any problem, could share the screen and we solve it together. Okay, great. Everything is working fine and correct. Great. Uh, so let me, I say send day one part one grasshopper on Discord and just want maybe. Funny thing to note. Okay. This loading failed. I don't know why. Let me check. Yeah, I would share the Discord again, but it's funny, I couldn't send the file anywhere. And here, invite people, and here is the Discord invite. Okay. It's funny. Let me upload everything on a Google Drive and send you the link of Google Drive. It won't allow me to send files. Meanwhile, if anybody has any problem, they could share his or her screen and me and Shagaya would answer your questions immediately. So put the link of a drive on Discord and also here in a Zoom chat. So if everything is fine, maybe I go on and oh great. So you could download that and I think everybody else could also download it. So let me close this grasshopper file. And here we have it again. Just let me make this group and we put a scribble of shading maybe here and click on OK. So we could do all sort of data analysis with Ladybug here, especially on tab of analyze data from calculating UTCI to PVM comfort. Let's do one other fun example here. I want to calculate UTCI. What is UTCI? It's Urban Thermal Comfort Index. Sorry, it's Universal Thermal Comfort Index, and we could use it on an urban setting. How? We have the dry bulb temperature, usually as the air temperature. We have relative humidity here, and here we have MRT, which is our mean radiant temperature. Okay. Here the MRT and wind velocity it has 2 underscore, which is optional. So let me move here and just click Boolean toggle and break my ugly plot here. Okay, let me hit these. And we have our dry bulb temperature, but it's not dry temperature at this time. This time is Universal Thermal Climate Index. It is what we usually feel if we go outside. And here we have a different condition from hot, neutral, and cold. But there is one component called MRC that when put any toggle in, it's set equivalent to our dry bulb temperature or air temperature here. But how could we get MRT? Here we have Ladybug outdoor solar MRT. What it would do would calculate the mean radiant temperature of surrounding. What is exactly mean radiant temperature? It's a thing. If you have a hot plate, anything like this, it radiates heat to your surface and you feel warm. Each surface with each temperature has radiation, and that's what we want to calculate. Its need location, okay. Let me bring it maybe more closer here on this front. It needs surface temperature. We don't put it here, and let's go on for other terrain. Direct normal radiation. diffuse horizontal radiation, horizontal infrared, and we have other parts here that should feel, but we could also not feel. That's it. So it's not single number or an hourly data which suggests the same temperature of surface around us. Okay, in very generalistic way, we could put up a dry temperature as our surface temperature. If we do, I don't know, energy analysis, we could have the different surface temperature and put it for if you want to calculate heat island or any concept like this. And okay, there is a toggle here. Let me just explain one other concept. Solar body exposure, and let me type the components here. Solar body parameters here. What is solar body parameters? Is that if you're standing, sitting, or lying, and your body location, if you're toward the sun or you're back to the sun, everything is different. And you could here define your solar body temperature. And let's not go too much deep, but here we have our MRT, just fun number of MRT. What I want to do is copy paste and plug in MRT to this one. And let us show the maybe condition here again. Here we could see if you put up MRT as a result, you could now see much hotter condition. Just to put it an example how your body location would affect your temperature, I put 0 for body azimuth and put it on solar body parameter. It's like I'm facing to the north. Now let's type 180 for facing to the south. You can see instant changes, and could also dive much more deeper and analyze data and get very, very cool result. But as you might be interested, so most of us are designer and we want to design. Here on our visualize tab, we have sky matrix that I want to go on. Here we have the sky dome. Our sky dome is a sky matrix. So I bring up Ladybug cumulative sky matrix. If at any time you need no rest or any break, just let me know. So in order to have sky, we need these type of outputs. For easier and much more cleaner, I bring up my Ladybug import EPW, but I would use this EPW file. So it needs location, again, direct normal radiation, diffuse radiation, and that's it. Here is our sky matrix, and here I have my sky dome. Of course, we could increase the resolution, put high density, and change the ground reflectance, but put it in a default way. So what Ladybug Sky Matrix would bring to us is variable thing because we could orient and check our design. How? With your Ladybug incident radiation. It's by default, it needs sky matrix, geometry, grid size, and run. So we have a sky matrix here. For my geometry, I would want to a parametric geometry, a rectangle that goes from maybe 3 to 5. And let me copy here, and I wanted to make it box rectangle. With height of 3. And here is my geometry. For grid size, I start with 1 as a grid size. And I would click on I would bring up a toggle and run. Let's see what just happened. I put it here and click here. And you could see how each different surface here receive solar radiation. Let's go for a maybe more fun example to work with. Assume that we have a rectangle one by one. Here it is. It could rotate let me, for easier work, and rotate object in a plane. Here is our geometry as an angle. Let me click and put it on degree. So we have 0 to 180. And let me bring my boundary surface. So I want to make a PV panel here and rotate, not by hand, to reach the maximum radiation. So the rotation could go from 0 to 180. And in plane, I put up X Y plane. And for origin, I put here. That's it. And I would just want to have another rotation. In which plane? In YZ plane, maybe. Maybe not. But what? Okay. It's wrong, and I would say why what I do here for modeling is wrong. Could anyone say what's wrong with the way I model this surface? It works fine. It's from 0 to 19, and for easier working with, here is 90. And it will also rotate fully. But what's the problem with it? They actually needed here the rotation. I don't know if you see my hands. Let me bring animate. If we have surface here, in general, in solar, we have azimuth angle here, which show the differentiation from a north. And sorry. Why might okay. And here, if you could see, we want our surface to have a specific angle in z direction. What I should do is just working with vectors. So let me clear all my drawing, and that won't work for me. Even if I do something like this, I first tilt my surface like this, and then tilt my surface like this. Why it's not rotating? You could see here. Is this problem statement clear for everyone, or I put it in more complex way? What I want to show you is that it's not very simplistic to just connect some components and get results instantly. Here, I could put this as geometry, and as a result, I could have radiation shown here, and I could check it out in my results. Assume it's a PV panel, and we want to reach the maximum radiation. What is the most easy thing we could do? Here, we could go to prom. We could bring up our Galapagos, and here have numbers. as our fitness and our angles as our genome. And maybe go here and write on things. So in order for us to see radiation change much more clearly, I bring my Ladybug legend parameters and put mean of 500 and max of 250. So we could easily now see the color changes. For example, if our surface gets completely horizontal, okay, it means better to put 150. And you see instant changes. If we go here up to north and here up to south. Go to Galapagos, maximize, and let me start solver. It goes through different iterations. And try to reach the maximum radiation. Okay, as you could see here in the result, we have something around 1,384 kilowatt hour per square meter annually. But one question remains here. Is it the maximum radiation that we could achieve? I click on Stop Solver and reinstate this solution. It said it should be facing south with an angle of 43. Okay. But we have here what's called a radiation dome. It gets a sky matrix as an input. And here it shows to us how cumulative a sky works. And our result is so much similar to this. You could see the little dot here. Maybe I could animate with it. Which is about the angle we have. So if you go to the max point, we have the point, we have the values, we have the compass, and also I don't like this projection because for me it's not very understandable, but in projection here, you could put it on orthographic. I rather to see it in orthographic view. Okay, I'll put some O, maybe the first O should be capital. Why I rather have this? Here I could see, it's changes in rate. The first line is 10 degree, 20, 30, 40. So it's about 40. And the funny thing is that the angle is not 180, it's more than 180. So we should maybe we should have something like here that lets the panel rotate even to the west. I put up this example because I usually see so many even dissertation that focusing on optimizing a PV panels or something like this. Okay, let me save this file. Everything was clear, not, or I thought too much maybe. Let's clean it up again. And hide again. Should we do the same concept when we are talking about the houses? What do I mean by that? Imagine here we have a rectangle, 3 to 5. I want to do it rectangle box maybe. With a height of 3. I could analyze radiation or something like, let us this time put different subjectivities. We bring up Ladybug Sun Pass. It will need location, and because we want to go in cleaner way, Ladybug import location, or import PW is better. And we just plug into the EPW file. And here we have location connected. And as a result, we have some paths. Okay. And here in Analyze Geometry tab, we have Ladybug Sun Hour, which gets geometry. Okay. Geometry vector from here, and I could click on a run. But it has some problems. Here, as you could see, we should put our grid size, and no hour is selected here. We could do HOY, or we could get analysis period. I rather go with analysis period and put HOYs here. So what here we have is that each surface of us receive how many solar hours. But is it rational here to analyze it in this way? I think not. Because why? Because we want to know how much our interior surface receives solar hours. So instead, try to came up with some solutions like 3 by 5 by 3. I go to code and think that we don't have this surface. An office, a fully glazed office. I copy the surface vertical and put it on desk level. Some of you may not see the interior of your boxes red because I've put up on my options, appearances, sorry, view, and display mode, and shaded my back face setting to red. And let's see why it would help. I bring up my geometry and click on this geometry and set multiple. And you could instantly see that you won't get any hours of sun. But if I flip this surface, it would reach to 4,459 hours. The orientation and the normal direction of surface here is so important. And bring again my geometry. And this time use these and set multiple geometry, this time as a context. Okay, hide everything and go to the top and even hide our geometry. Okay, here you could see the 1 meter by 1 meter grid size is too large. For example, lead suggests 60 centimeter by 60 centimeter, but here it go much more smaller. Don't go too small like mine. It would probably, I regret now I haven't saved the file. Okay. The graph is worth it. Here is clearly shown that the sun would not penetrate so much deep in space. Of course, we could bring up our maybe first save and go for something around 0.3, and after that, bring our legend parameters and put 0 to 3,500 and cleaner legends. Okay. So how we could do this more parametrically? I want to go back to my Rhino example and maybe go something like this, that we have surface here. I think I've put it on a height. No. So let's go back, and this surface. Put up my geometry here. And want to do an scale here. Set one geometry. Get the area for the center of scale. And factors to go from 1 to 1.9. Okay, not that much far, 1.9. And the factors both works fine. And get wireframe from both of them, this and this, and join our curve. Okay. And we could go now with ruled surface or loft or anything you like. As a result, I now have so let me put it much more clearly so everybody could understand. Here we have our geometry and toggle to false and put here a merge button. Internalize this geometry and internalize this geometry if you want to work it later. And let's put wireframe here and preview swatch and use black color. It's just for preview, no to brush or it's our context. Oh, sorry. Here we have our context and here we have our geometry if you want to see. And what we want to do is as because I bring the preview panel. Okay, let us. Everything is fine, but let me bring up the mesh maybe. It's funny because we have it, but it's not shown. Okay, everything's fine. And sorry, I haven't checked this. So now we could see the effect of going up. Let me change the grid size for easier simulations. We have now 90% window to wall ratio. It means our southern wall have 19% of glass and 10% of opaque wall. And you could see as we go lower, and if we reach the suggested X-ray window to wall ratio 40%, it's almost like no sun will reach. Of course, you could go with different angle, orientation, or window size or geometry. And work everything fine. So is there any question, concern, or something like this? Okay, saved it. I think we are good to go. Am I right? There is much. We have a question. Fitness function, colorful components. Okay. Let me group this one and go to the colorful question. Let us put Galapagos. Let us show this. Okay. Let's see one thing first together. We have here results, and what I want to do is go to mass addition and add up all these results. It has one problem. The problem is if my grids go higher, something like 1, the result would be significantly changed. Why? Because here results show each point here receive how many hours of sunlight. So in order to put something like this in Galapagos, we should came up with a solution that show united number for this. In order for that, I multiply my results to my grid size. Or not mesh my grid size. Here, no matter how I change my grid, we have, it's very important. The result we have is direct sun hours per square meter. No matter you go to smaller grid or larger grid, but the change is here. If you go to smaller grid, you would get different result. There is one other thing we should do. We should also, if you want per square meter, we should also divide our results by what? By the square meter of our surface. What surface? This geometry. We get area from here as input. And we have much more cleaner result. I want to go to grid size of 5 and see the result change because we have now more points that the direction reach. If we go lower, it much because the amount of surfaces or points that's reach the sunlight hour change. That's called point if you're doing, I don't know, sunlight hour analysis, dayland. That's why the I don't know certification like lead emphasis on exercise and how it is distributed. Okay, I go with 60 centimeter by 60 centimeter. And here I bring up my Galapagos. We will optimize here our fitness is this number, direct sun hour per square meter. The other thing that is changing here is this genome or window to wall ratio. Of course, now the result for us is clear. Would reach to 9.9 and click on Start Solver. And maybe zoom out a little bit on both fronts. You could see it's changing, but you could see easily Galapagos is not fit for this simulation. Why? Our solution space is very low. We have limited choice, and I stop the solver. And here have the population size of 50. While we have 10 only instances. So we should change these parameters. Let's put it something like 5 as a population. And again, click on the start. Even 5 is big for this simulation. But you see, after 5 results, now have some results. And so it was, I do it exactly to say, just plug some component to Galapagos and run. These options are so important. If we didn't change this to 5, it will never show us any results. And if here we click on reinstate to show the maximum option, it goes to 0 because 0 means we have no glazing. Okay, fine. No question. Let's let me ask a question. I go all the way up to 0.9, and here we reach to 3,500 hours of sunlight. Is all of it good? Does it and sometimes bring discomforts like glare, like I don't know, overheated radiation, and etc. Of course, all those hours is beneficial for us, but how we could get which hour has what value? Is it good? Is it bad? One solution that we have in front of us is using other components we have here, like direct normal illuminance that we have here. What does direct normal illuminance show to us? As you could see here in the unit, it's illuminance, so it looks. We know 300 lux is fine for us, and beyond like 1,000, or in some literature they would say 3,000 is hard and comfort. As what we did earlier, we could somehow do calculations to see what is perfect light. Any question, or I don't know, any suggestion? If you want time, let me save this document again. And group this one. So yeah, exactly, I was going for a break. Let me stop my sharing and save the file, but I want to ask each participant to open up this file that I'm now uploading on the Google Drive. Again, test everything, and if they encounter any problems, so whatever, just say to us and we'll try to fix it, because after you could see at each step we go deeper for more, I would say, meaningful or more decision informed solution to our architecture. No question. Great. See you in 20 minutes or less or more than 20 minutes. So let's have a rest. So I'm back. What about others? Should we start? Okay, we'll definitely internalize data and no other comments. Any are presented. So should I share my screen and start a new chapter maybe? Hi, Steph. Would anybody have any question? Okay. I share my screen. If you have any other question, just let me know. Okay, here it is. And here is my screen. Internalize, and I want to start working on a new canvas. So what we want to do in this session is go to the Honeybee tab. And let's assume that we want to work on the same project. We have a bedroom, but this time different. 1 to 5. And I put 1 to 5 again for my rectangle. The result is this. Okay. And what I want to do is equalize the area of rectangle. For example, the area we have right now is, sorry, 25. I wanted to reach to area of something like maybe 20. So what I would put here is wanted area. Shaka, if there is anything
Yes,
you
could you please add bifocal? Sorry.
Oh, okay. I think everything is good to go. So
Great, thank you.
you're welcome. If I divide my geometry by geometry of what I want, I would reach 0.8. But if I scale by geometry with the area, we have center here, we have geometry here, factor. If we go again and ask for this area, we would not get 20. Why? Because we are dealing on 2 dimensions, so we should have a square root. If you add a square root, it's now no matter how you change the geometry, it's always equal to 20 square meter. Okay. We should change some part, but let's go on with this. The next part I want to do is rotate my geometry. Now, I could make it a box and then rotate it or something like this, but I'd rather do this transformation in earlier stages because of the computing power. Okay, we have area here, angle here, put it on a degree and go from 0 to maybe 180. And the plane is this, and let's check it out. Okay, let me put it. Okay. As you can see, 0 to 180 is too much. We could easily go from 0 to 90, or let's leave it here. After that, I put my box rectangle. Here and go with 3 meter high. It's like a room we have. After that, I would go to my honeybee, and here I have a component called honeybee room from solids. I bring it up, add geometry to it, and if you see nothing is changed, it's because the output of honeybee room, the output of honeybee rooms are room. If we want to visualize room, we should go to this step, which I want to see visualized by type. Okay, we have room, but it has no surface at all. And therefore, I go to honeybee aperture by ratio, add my room, and here I want to add what we call facet parameter. That's we could define the ratio of glazing ones. I want to go from something around 18 and let's visualize this. So what was the problem I was talking about? The problem that we face here is that when we change the angle dramatically, the window shifts from this surface to this surface, which is not desirable for us. So what we should do is that I delete the rotate component here and go back with this one. And what I want to do here, we have HBU rotate. So now you understand why we need HBU rotate. We got HB object. We put the angle of 180. And here it is. You could see it's total back. And if we change it, it stays on the surface. So let's put it to 0 to 180. That we don't see dramatic shift. But as you could see, it's rotate around the origin. We could change it by adding origin. Okay, and axis and now you understand why we have HB scale, HB rotate, or HB move here. And the fun thing we could do, we could always change the window to wall ratio here. But we want not to reach to 1 because it would fail. Okay, if I put 0.9 here, it bring up here, but we have -1 here. So what should I do? That I put 0 to 10, and in expression, I would type x now I have 0 to 1, and now I want to say it's a 1 to 9. We have optimized the components by its expression. And let's put 0 here. We could have it done for your surfaces too. So we have our rooms, everything is going well, but what's all necessary thing to do? Here we have walls, interior wall, roof, ceiling, everything separated. If you're using any BIM software integration, I don't know, ArchiCAD, Rhino to Revit, it's really helpful to use this visual components. To go, I want to only a window, and here we could somehow bring out toggle, and for example we have horizontal and vertical separation or anything you want. If you to I don't know, change the geometry, anything, I try to set default. One thing to notice, window height default is 2 meter and the sill height default is 0.8 meter. So rather to put the sill height default to 1, or better to say X. To have it window positioned on a certain height in order to have, not very hard or of a scope. So we have our window, we have our geometry. Let's, for making it more interesting, add HB louvers, and one steps goes from 0 to around 1. So remember everything after this HB object. So here then I put 0 to 10, and in expression I type x divided 10, so that I this deep louver to this, but I want to add another thing. I want to also add this to distance between. Why? because if here I put 90 angles, it means closed, open, closed, open, closed. So let me put 1 to 9. This time x multiplied by 10 and put it on an angle. And as you could see, if I decrease the depths of the louvers, we would have some different. Of course, you could flip it, change it, anything you want, but that's all at least I need. Oops. Plug it into HP Rotate, and let me just clean my canvas. Does anyone have any questions so far? Any notions means somehow good to me. I have room here is great, but I want to do what I would do in last part, and this time with radiant. What was it? I want an daylight into my space. Again, starting from 0 going up. Here, we want, we should uh, models, but as you could see, have HP and HP room. So I go back to my honeybee, and here you could see HP models, and I play room here. So let's go back to HP radiance, and now I could get source of my grid from room. Of course, I should define my grid size is 0.6 for grid size and point from distance my floor, which is the distance of or height of your table usually. And I should assign my grid and view to my models. I have grid and I have this model, and that's we need. We have the model here. Here we have modifiers. I want not to get to the modifiers, first get to results. I bring my light source. It's HBVAA from EPW file, okay. Once EPW file, I do some cheating here. And it's my EPW file from here, Control C, Control V here, and here is my file for light source. It's funny, here we could also visualize the sky, but not our way. How we could make sky VAE from clear sky? It needs location, oh no. Here we could deconstruct or make, sorry, maybe come up with some standard sky and then go for. Let me go to log, bring up location from EW location, and what here we have is HDR, so we should go to late deploy. image viewer to see this HDR. It's clear sky, so nothing is presented, but we could go back to variance and climate-based sky. And let's see the skies. You could see no difference here so far, but as interesting as it is, the value is if I bring up my false color, it's not necessary. I want just to show you how, again, different things mean different type of geometry. Here you could set 3, I put them to 80, and here is our clear sky, here is our clear sky. You could see very huge difference. So we don't need this because we are using the VAEs. And above all of these, we want to go for annual daylight. We have VAEs, we have our model, and I want to put Bulldogger and run it. Here it makes dark sky, total sky, direct sunlight, and now it's doing calculation for steps and hours we have in order to have annual daylight. I don't know how many of you are similar concept like spatialized autonomy or continuous autonomy or etc., but we will cover it in this. To visualize the results, I go back to my ladybug, bring a spatial heat map. We have our value here and we have our mesh here. And I want to just see the wireframe, so I put curve here and hide. Okay, you see the daylight army we got is very chaotic. It's due to the fact that our grid size doesn't match with our space. So I know it's against the law and everything. I go one smaller, 0.3. Here same image sky matrix. This is the process is similar what we do with sky matrix as what we do with sunlight hour, but now with this setup we could change geometry and it's which is very helpful. Now you could see it's forming more meaningful results there. So I want to go one step further, and that's to go to my HB radians. And what I have here is gets DA from me. It gets mesh from my result, and it gives me something called spatial daylight autonomy that we will dive in deeper. But I want to do one other thing and turn on my profiler. Profiler show how each components take to be calculated, and you see here the most time consuming component is our annual daylight. I put it on a false. I don't want to do anything crazy. I go with 3 to 5 room that I've got, or maybe rather go to 5 to 3, which is show deeper. And what I want to do, maybe into depths of my lower to 0, and I want the only constraint to be changed is a 1000 window. So let me save for day 1 part 2. So my main question is, how many of you have a TT Toolbox plugin? If not, don't worry. I do this part faster, send you the link of downloading TT Toolbox and showing what I want to do all this time. In TT Tools, we have a component called Brute Force Classic. That is very great. Add up my source window as its as its seeds, and also my rotation here. And if I click on a toggle, and they said the total premium around 1810. Why? Because when we rotate degree by degree. I'd rather do what? Either divide x to, and instead of 0 to 180, I have 0, sorry, x multiplied by 5. Now step change every 5 degree, and permutation suddenly dropped to 370. Actually, it is too much for me because it's brute force simulation. So if you do brute force simulation, calculation for each and every instance. Thanks, Charlie. So I'd rather to multiply it by 10 and have it 80. So now it's at the step of 10 degree, and we got 180. To be honest, when I knew it would take 30 seconds to run, I could calculate is 30 by 119, and if I divide it to 60 for calculating, it takes me 5 minutes to run. So I go for x multiplies 30, and we would have 0 to 6. It seems fine to me. And we have 7, which is actually fair. There is one great component here, which is write Excel. If you have, I don't know, if problem with showing the abbreviation of the word, you could always display and ask it a full name. Maybe it's better for you now. It said what are attributes you have and the location and thing you have. First thing first, I want to merge what I've put in my notation. This one, the angle, and most importantly, the result of this. And I want to put record at the end so that my data recorded. So if you clear and let me make this to false, make it to true. You should ask me a question truly, because if you don't, I go deeper and deeper and deeper. So here we have our results. I think the grid size is so much low now. What the number we put here? Okay, it's definitely could go to points. Feel free, because I want to start running on brute force, and it would take me 35 minutes. And I put lectures about the concepts in these meantime. So we have our data like this. Why? Because what we should do when we run this is we should simplify inputs and results. So again, my grabber just hangs and let me open it. So wait a little bit. So let me click on simplify, simplify this input and simplify this. And maybe instead of simplifying the result, we could do a more easier thing, and that's fitting the result. And since three input, we could go to set list and partition list to size of 3. To show the result, because I think after showing you the result, you easily see the benefit of it. It's so funny. Okay, let me change, for example, to 400, 40% for window wall ratio styles spacing. Okay, there's no need to do the things right now. I want to show you the result. We understand it. Always the profile for you to try it out, but computation time and calculation for each and every one of them is really killing it. Oh, no, no. So we have our data chunk like this. And if I put it as, oh, sorry, as an attribute here, um, and if I go to my TT toolbox and on Excel, and I would bring right Excel Classic and put this as my data. And I could define workplace and everything, but just open up my stream and Boolean tool and click on stream. So what it would do is just open up an Excel file for me. So the result could be written here. So just let me check the problem with it. Data is correct. Let me flatten it. No. Address is A1. Okay, everything is fine. And let me put up a number in it. Okay, we're fine, and put it on a location. This data. Oh, we had null data here, was causing a problem. So let me save it and send the link to send this to here. So it is it, and I'd rather to stop sharing and see what you've got till now. or anybody does have any questions so far, or file is downloaded? Yeah, of course. I want to let me share my screen again and show you what is the value of fixing data. Okay, and here it is. Rather make it as set and maybe trim pass, trim tree. Okay, the depth was too much. Simplified. Okay, I think we do one other analysis. While we do the analysis, if we have our data in Excel, or we could export it in any format that we like, and it's easier for us to make comparison or go back to the result, or do something like this. It's funny because today I figure out that TT Toolbox released a new plugin. Let me click that Shaqaiq has provided. Let me Control C, go here. I think here no, I don't have TT Toolbox. Why? What? I don't know. All object happens. So weird for me. You know, when it writes this data here, we could see different okay, I came up with some solution. It finds the item. Till I do this, if you're like me, TT toolbar 1.9. I'd rather use this version because of component called Collide, which is a great component. I show you why. So it do its analysis. And here it is, and here it is. For null item, everything looks fine. So I click here and toggle it to true. What it would do, it would run the analysis, export results to Excel file. After each analysis, we could know SDA, the rotation, and the WWR of each. You could see here, window to wall ratio equal to 0. And when it's equal to 0, no, if you can rotate, the result would remain the same. What this component does is just doing brute force analysis. Brute force optimizations are, as this is actually not optimization, brute force algorithms run every possible scenario to find the optimum result. And one thing to notice, we are now doing a 5-phase study with our rates. Okay. And the list will go on. But what I rather have, okay. Could not stop it. Okay, make it to false, please. It needs some patience that I don't have it right now. Come on. I'm pretty much when I click on escape. Imagine if it was. Okay. To my test manager and just end test now and open up my Rhino again. So let me open up my old but new TT toolbox and go to Grasshopper. And go to special flare comment folder and here it is, my TT toolbox. Now I should have both them not work together, but let me try it out. It's here, but let me type colibri. It's so sad. Okay, ignore verify. If a view hasn't installed or downloaded the new TT toolbox and want to install toolbox 1.9, just let me know so I could show you how you could get the benefit of using Collider. And let me toggle this to false and set this and simplify this and get to our data. Here I want to go on new brute force. Let me, here was my input, and let me zoom in. Here is one of my other inputs, and that's it. And I toggle it true. I hope this new component wouldn't crash. Or it's, and let me change the grid size even to higher ones so it could calculate much more faster ones. Okay, I didn't run the components. Let me toggle it on true. So let's do one other thing, and everything seems fine to me. Click true. Maybe this time. Any question after all these tryouts? Okay, you're fine. Here is the result. And if I click on my permutations, I would get 0 and 0 and permutation 70 by 70. This goes fine, but let me change this to angle and this one to my mouse. So we go back here and bring back brute force, bring back my number, and toggle. And here is the angle. And that's it. I want just change the number for annual data. Let's make a file. Never update or go for new toolbox. Okay, my computer again. I this crashing over crash. Let you have time review the first parts of the file. Oh yeah, which one is older? I want to delete the old one. Delete, 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 delete. Now I fortunately have two TT tools. No, I think it's fixed because I was not expecting a huge difference. Here we have Colibri iterator. As you could see, it's somehow the same, you know. Here I put my inputs. And my second input. And that's it. And more important, here we have image, which save image from our Rhino screen. Oh, no. And another very cool thing we have is a library aggregator. We get iteration, genome, our image set, our iteration results, which are our results here. And also you could have your tree file. Let me delete this and this one. And now with the iteration, we should have the iteration genome and click on toggle and put it on a true. iteration genome is okay for me, but let me put it like this. South glazing, and what I want to delete all these actually unnecessary parts, and I want it here. It's change the styles glazing. Here I write a name angle, and that's it. And as a result, we have our okay. Our SDAA is gone. We go back on view radians. DA and have the SDAA as a result. Yep, I'd say thanks, Shara, because I wasn't expecting, oh, I should, this much of difference between these two objects. And just today after class, I updated it. Okay, as a iteration results, let's go back to Colibri parameters and data, no, SDA and S iteration result, and it's true and recording started. So let's go back to this PC, C, Colibri, and we should have the image also, image setting, Rhino view name, or image saved name should be maybe combination of these two numbers. So I go to maybe run it a flight test. Yes. What I would do is just make a folder, have the Excel data written here, and you could always access it through here. They separated components to different components, which make it work with it a little bit harder. And it would give us the data, the result we want here. So let's save this one with easy. And just for making our text input for image name, we could go for text and concatenate, and I want to first one with this, concatenate with this, and this works. So it's made some wording for image, save name, and so let's check this viewport, and this it is. And everything works fine, and let us to remote flight, or maybe just one other flight test. And now we have even our pictures here that you could do, some animation, something like this. So let me go back to I want to do one for better showing the result. I want my wireframe background be solid color and be white. And I want to set my view to isometric, and that's it. And one thing to also consider, I have what's very good here is just capturing all the pictures and changes by setting up a, for example, I want now the wireframe to be black. So let me make it to 0.6 again, and the preview here go to another preview. If you have the human plugin, maybe you could go and do something more interesting. I want to add my color swatch and make it red, and even go further and just for temporary ask to not showing the grid. I should have clicked on OK instead. Grid, and use mode specific and turn grid off. Grid access also a very clean shot. And that's it. Gonna fly, and yes, and yes. Oh, I didn't turn the toggle. true. And here it is. If you're worried, don't be worried. I actually have prepared some GH files for you to work with it. And here is our mesh. And in order to get rid of the parameter, because every time if subject change, we lose legend parameters, I give it 0 to 100 maybe. And plug it to legend parameters and turn these off. So let me check the image. My view is not centered, unfortunately. Let me go to this and go back to my grasshopper and middle click on this and maybe middle click on this and a little bit zoom back with centering the geometry. And let's click on it. It's run 63 simulations for us. And it would sometimes. So if you want, we could have some lectures or some go more deeper on what we do. Now let me type daylight autonomy. Autonomy. That's what we are analyzing. I thought the first, but I would suggest you more in depth. In order to calculate daylight, we have different measurements and methods. So, of course, here, when we want to calculate the amount of illuminance, our measurement unit is lux. But as you might know, every single hour we have, our space has different lux. So what do if we want to calculate daylight annually? You could see this pop-up black screen is just calculating, and here you could see the result that we reviewed. So in order to calculate the result, different people come with different metric. For example, come with daylight factor, which is related mostly to orientation of those, and it's easy to calculate. Other persons come with daylight autonomy. What was daylight autonomy? It has a target illuminant 300 lux and a threshold of 50%, meaning 50% of the time the level above the 300 lux. So one other question, what is spatial daylight autonomy. It didn't talk, as you could see here, about single point. We want to calculate subject from small and space related aspect. So people came up with daylight autonomy. One thing is full daylight is that from a range of, for example, 100 to 300 log. But unfortunately, it's weird. I think this the Marovich, the uh, writer of the paper, has changed the target of UDI in his recent paper. It's funny, it's not reflected in Vlog site. Okay, what site I would suggest for bring out these results? Uh, Climate Consultant is other software so much similar to Ladybug Tools. Oh no, climate still. Sorry for Mrs. Uh, uh, that give insight on different related like what is daylight, what is useful luminance, and the list would goes on. I click here on a learn, it will open it. Since getting the license was so hard and the grasshopper front of their compound and their website is not so much friendly, we'd rather to go for Buzz, which is free and working more smoothly. I think the problem is my location, maybe. Maybe refresh it and hope it would. Till this website trying to get open. Here you could see the output results. Finally getting open. You could also go for free climate studio trial. If you're in a university, you could go for educational licensing. And it has tutorials, different data for how you could use it. And what I want to go for is lead version 1. I'll wait a little bit till it gets open. One suggestion: don't do simulation, especially brute force optimization. It's here. I will send a link. We have different rating system and default on daylight availability tab. You could go for different option like and lead version 4 option 1. You could see here. And here they say what is SDA and what has changed in lead. It's a spatial daylight autonomy, as you could see here, the guideline, and everything. So I would send you this link so you could check it out. And chat, here's the link. And let's go for something that I was curious of it. And that is if the UD here is correct or not. So we calculate SDA, we could calculate ASA. I'll show you the workflow on Ladybug Tools. Maybe on custom. Let me go back to my library. Okay, not bad. Since it takes sometimes, I'd rather click on escape and you got familiar with the concept. It's very absurd, but I have no solution for it. It's because of that I right click on a component and create a test file. Because when you put it on a fly mode, it would calculate every single scenario and there is no stop to it. you could see how it actually exporting every image. I save it and go to my part here. Let me delete this one and send this one. While we do this, let us review what we've done. So I'd rather click rectangle here. We made a rectangle. Since rectangle, when we change the as width to length ratio, change the area, we came up with a solution which involved a grid of dividing to scale. The area was the area that this geometry had. We came up with a solution that the scale remain 20, area remain. Then we need to box rectangle. After that, go to Ladybug tools. We go to okay, interest too. In Honeybee, we clear room from solid. As we said, we start from 0 and go on. As the result of Honeybee component is room, it needs other components to visualize for us. Okay. After that, we add something, especially to south, that we could change its, I don't know, window to ratio. Window to wall ratio is a concept that tells how many percent of this wall is allocated to the window. But to do it here, we have the components that's talking about the shade, bring HB apparent by ratio with facet diameter is this one that has north, east, and south. After that, we add a lower, and since by changing the rotation in initial steps, we'll get a bad result, especially on locating window, because it always wants to locate window to the south. We came up with rotation here, and it would rotate our geometry. After that, in order to get this simulation, we needed an H model. So we create here HB model, and we assigned an interior from HB grid, from an interior grid to arrow at a specific height. Let's show you here. The height of the why? Because we assume this place office and people work in office, so we want to know the amount of illuminance from, it's important, from the weather data that we have generated, and we want to use these as our base weather, the model, and after that we click on run. That's it. I could do this. And for last part, we added a colibri iterator because we want to export image, and so we want to export the result in Excel format. what it do for us, let me open it this. It made an Excel file talking about different input angle and output. And as you know, we escaped some of the result, got minus 99. And here are the images. This is good. We have time for doing, some GIFs or some animations. Do you have any question, or did I don't know, just because of the new TT Toolbox update, I get so much views, but we could go for the last version and use Colibri easily. Oh, let me stop my screen. Is it 20-minute break bad or ugly? People got frustrated at first, maybe the room. Hey, thank you so much for attending and being present at the workshop. So we could go back for 20 minutes later, maybe, and go for the last part of the workshop. See you. So it works fine. Hi. Am I right? It's hello, Siad. Am I right? Loisa. Pronounce it. Sorry, Mrs. No, it's fine. I was not sure how to pronounce your name. Uh,
Ah, it's Brazilian, Heloísa.
oh, this doesn't pronounce great. Alois. Am I right?
Yes, Heloísa.
It's nice to have you here in this workshop with us.
Oh, thank you.
So I think people are coming, and let me share my screen again. So I again click on true here to do some daylight access. Why? Because right now, if I go back to my Honeybee Radiance, I could get CDI, I could get different metric like UDI, and also put on my average and toggle UDI in and put it as second input, or CDA or any type of analysis. That's a advantage of using Ladybug at this stage, that you could easily toggle in different components and have the results written on the Excel sheet. But after this, after the initial simulation, usually people go for HP energy. And if you have noticed, we missed these modifiers that we will talk about tomorrow. Tomorrow, focus on metals and how we could assign metals. Just go to Honeybee Energy, and I don't want to follow steps like before. I want to go to the rest result, file, simulate, and click on annual load. So let me check what annual node needs. So it needs to have room here. It needs EPW. I have EPW here, but I toggle it wrongly. Here is my EPW. And at last, it needs toggle, full toggle, and run. Now we have cooling load and heating load. As you could see here, it's written, it has 12 values. When it has 12 values, suggests us that we should go for a visualize tab monthly charts. And we could see cooling, heating, lighting, equipment, processes, and hot water are empty, but we don't mind. So let us show and see the result. It is evident the coloring is not right. So in order to have coloring right, we could go for legend parameters. And maybe go different colors, but I'd rather to somehow change the wiring first. Input cooling, then lighting, well, maybe then heating, and that's it. I don't need equipment. Okay, we see it's Germany in winter months. We need high demand of heat and low demand of cooling. And it is kilowatt square meter, so it's normalized. You could see easily we have our energy beside our. Let's go total load here and check our total load. We toggle in total load. It's total load each and every of them. We came up with mass addition. I could again now, let me first make this false. I could again now go to, I don't know, something like Galapagos, try it out once more. Our fitness is total load of our energy. The genome would be our galactic and station. Oops. So to make it more interesting, I want to make it 300 C. So it rotates fully. And you see here, how many number do we have? 6. How many number do we have here? 9. So population size even in stage won't work. I should put population size something like 10. And I want to add another fitness at this stage. This one, I delete this, and go for our visualize, and again go for our isometric view, and that's our Galapagos. It's a population, the population size trend range means it's low result, maybe 20, something like this. And most importantly, we don't want energy use to be max, we want it to be minimal. So that's it. Let's start with solve. You could see the changes. in energy and in if you click on a first icon here, you could all the results it's simulating. Different band lengths, the rotation, the window size is changing every possible aspect of this to achieve minimum energy use. Here you could see how different list of number have assigned to this. We have from 200 kilowatts hour per square meter to 186. I think now is evidence that maybe genetic algorithm is not very fit for energy or data optimization. And it could goes on just to show the concept. Click on stop solver. Okay. Till now, here is our optimum result, which ratio to 3 with glazing of 30% the cells. You could do much more complex objects and data. It's so easy to see how we could get energy analysis. It's so many tabs, and let's start again from the zero. It has all the things, but I bring HP adiabatic by type. What is HP adiabatic by? If it was a room, the only surface that heat transfer from was this surface. So I should all these surfaces adiabatic means it wouldn't count for heat transfer. I go here, I toggle this, and for each job, especially on exterior wall, I go back to my HP, bring up again facet parameter, and for exterior wall, I click on the toggle, Boolean toggle, north, east, and west. And if I put it here, you could see the color instantly change. And also toggle for expose for, and that's Now you could see energy drops a little bit, not too much. But maybe we want to go for different paths. What do I mean by different paths? I want it to optimize heat load. Let's do this. I want first item. The first one is cooling, the second one is heating. And let's go for fitness. And let's run calculus again. And we go this time for 10, minimize. Now that we have an optimized solution, better to click on the cascade to try shape and start slide up. It would start from its initial now you set. You could see the results are not from the comparing to the lab is not directly changing. It look for solutions around your initial state. You could see that I again click on solve it, and the fun thing is that what we have here is window to the west to it's not a very good solution and it needs some more optimization. But why would happen? Because it was, if you see here, it is trying to change its gen is less exterior because it's not meeting the interfaces from our energy calculation. Any question or anything? So if everything works fine, let's me go one step further. And that would be go back to honeybee energy. And beside the annual load, you would see something called peak load. Its input are almost the same. It wants room, and we have our room here. It's wants Wi-Fi, and I toggle the run. What it would calculate is peak cooling load and peak heating load, which is an important aspect when you want to utility system, HVAC system, and if you want to choose this system, you should go with this number. And minimizing this number is also important. So we have total load that should minimize, also peaking and peak cooling heating also minimize. So what we do? In these stages, we could do two things. First, somehow came with solution that remap these number and this number and making it to a single number. Why? Because Galapagos or many optimization tools accept only one output as their optimization. So we should have two outputs, or we should go for different component. But let's show you how again assign. Sometimes if you drag this fitness, won't get like this. For those times, you assign it to a number and get fixed. And you double click, you could set number here on fixed. For example, you could say 1. You could say it will get to 100 or anything. But in general, we want it to be minimized. Any other questions or? If not, I'd rather we go on by Octopus. I have the link here. I downloaded but haven't installed it. It's like old Ladybug plugins. You should go to file, special component folder and install it here. Octopus and Control C from here and Control V from here. Save this file, click on Files and close my, you could on Grasshopper, but I'd rather close everything and from the beginning. And file and the part 2. Now you could see Octopus. There's a lot talking about Octopus. As you could see here, we have a genome and O for Octopus. For genome, we go for total load and we could set up different number for cooling and peak heat. It's easier to change the names, something like total load here, heat cool here, and peak again, this one, and this one. In other software, you go exactly the same. And for genome, we have this, and of course, angle, and of course, the glazing. We double click it. And here we have our octopus page. As you could see, the parameter assigned each are on a axis we have. And we have again patient size here are set to 100 again to. It's very important. I usually see people just the results and on the simulation with no to know how it's working, why it's working, that number main, and just click on keep extreme, and that I click on start. The great thing with Galapagos is that it minimizes all the your rhino faces, so it's much more faster. And but fortunately, calculating each simulation take time. And now you see why it's important to have some Excel file that is recording each simulation and result, because it's really, really helpful now. We know it's running, but nothing is shown. Why this is low? Because of the population size, because of the intervals and the list goes on. Okay, let me stop it. I stop it to check if it's encounter problem. Yes, it does. It deletes Galapagos and delete the components and save file. Go or running again. Stars. Okay, something is showing. Here you could see the diversity, how different number are from another. Sometimes you lost your canvas here. It has cam and Q view. They would for better showing the result and diversity you have. I'd rather to have it again reset. Click up. You just the result. Here we have cam, click and read. You know, here we see peak load, the total load. Okay, let's change the axis. You could see here peak, here peak cool, here total load. And if you see it from above, you could see easily which one, cooling effect and heating effect on the total load. I generally rather to use Octopus course with correct setup than using Galapagos or another platform. Do you have any questions or something like this? Let me save the file. And go back here, delete last one. And upload this one. So let's go and search regenerative design. And I want to search Google by regenerative design. And as you search Google by regenerative design, you'll mostly or probably came up with this diagram. I try to open up this new page. Okay, let me show it just here. It's so weird because it's stream on YouTube, but the connection is not showing the pictures. Let me go for the last part and to Shagaya to show you and talk about the diagram with you. Downloaded the Ladybug tools. Here you have samples. Ladybug samples, for example, calculate outdoor comfort. It is like what I did. Compute MRT, calculate UTCI, different result, and time of convert. They are designed to something that we have done, radiation study and radiation phase. I highly suggest that now you get familiar with interface, go and check these sample files from this part, and also we somehow cover like the pipeline of annual daylight in detail and visualize this, compute the area we do all these necessary, or something like creating a sky. So as you might say, we have results and sample file we need. Therefore, part of this workshop or as a practice for this workshop, we in Digital Future are expecting a project out of this workshop. And شقایق now when talking about what would be fitted for this workshop, our result is simple. Please go on Google Excel sheet and based on your capabilities for a team and choose a location. I don't know, you want to use your city, don't duplicated location, choose any location you want, and we want you after 3 optimize a design that works well with generative design set that Shaghay would be putting you now. If I miss anything, Shaghay, please remind me to catch up and follow.
Thank you, Iman, for your really good presentation. And you cover all the things that you want for this session. So just I wanna speak about the regeneration, and maybe it would be better to speak about that for next session, but I don't know. You can continue or not. It better I speak about that for the next time or no. I can share one file to our participant, but let me send it.
Maybe if you could share the regenerative design diagram from conventional to generative, it would be great.
Let me. Where is it? Okay. Is it clear?
It's clear for me, and I think I could see it clearly.
Okay. Well, as we mentioned before in our introduction video, we put some information about the generative to regenerative model. Well, during this session, we talk about conventional practice. We change some part of our house, like window to wall ratio or other parts of our building to find the best solution for achieving the best things for heating and cooling part. It is a conventional practice, but we have some other meanings in the sustainability or regenerative design. During this way, I wanna, okay. In each step, we change something and all of them have some meanings. For example, conventional practice is just basic parts that we change something and modifying something step by step. But the green is same as the original version. But sometimes we consider our environment and put some efforts and do some things to improve our environment. In sustainable design, we want to connect our environment, economic, and some parts of our building to make a sustainable environment and building. But you know, when we change something, for example, when we build a building, sustainable building, we put some efforts in on our environment. For example, we destroy our nature or other parts of our environment. But in regenerative design, we should consider all parts of our life, our environment, human, and buildings. Well, during this way, Iman and I, to the next session and the third session, we talk about and we optimize some part of parts of our buildings, such as energy systems, building materials, and the comfort of our environments for the residents. It's a regenerative design. Well, for the next session, we have a guest from One Click LCA company that will join us and put some and give some information about LCA and some elements about life cycle assessment. And then we'll keep continue in the third session to calculate the carbon emission, carbon design, and build our environment as better than from the past. That is the mindset of a regenerative design. Okay, and I will share this file with you. Maybe I share it in Discord. Is it okay?
That would be fine from me, but I don't know from others.
Okay. How can I stop it? Great. If you have any question about that. Okay, great.
Okay.
During Sana, we will share all the documents and links on Discord and our Google Drive. Yes, I will share it with you. Let me share the Discord. What is it? Discord link.
Okay, if from the Sinus comment, I want to reach out to others who presented in workshop. What I say seems reasonable or somehow okay or not. It's weird. Nobody had any quiz. At least it's weird for me. Okay, no question. Great. Thank you for your attendance. Please have time to follow the Grasshopper file that we've shared with you on Google Drive, and also check out the Ladybug example, especially maybe hybrid not necessary now, but get familiar with. I will some files with you also, especially tomorrow and at day 3 that will give you understanding of full workflow, how to interpret from early stage of Ladybug tools design to the way up to the regenerative design, and what Shara would share with us. Hope you well. I have no question. Maybe we could stop this session, but and our
Hello guys, can you listen? Okay, sorry,
Definitely.
in the introduction sessions. Now I try to connect to this website, Discord, if I'm not wrong. And I see I don't have any access to the content like welcome announcements and like this. I'm wondering if you have to provide the permission, or I don't know, maybe I'm doing something wrong. Yeah.
I should have others also in here. I think I open access to everyone, but I'm not sure. But I'm opening up my server now. The third session would be Monday. So Seper has access to Discord. Let me check it again. I'm again the invite in Zoom chat, and I accepting invite and access the server. I think we should have access to all the data. Is this server works for everyone? To get a short from all, let me share my screen again and go through the Google Sheet file. Thank you for filling out this form. Thanks so much. Actually, if you see here, we have team forming, and I think just one group for team, and that's missing too. Okay, it would be great to I'll wait a little bit to be loaded. Please go on team forming sheet and form a team of 3 and also choose a location you want to study there. Okay. Eliza and Anderson and Davey form a team. Great. Me put up a set location here and type the city you want here. Location. All of you do the same. Eliza, Anderson, and we do this. Let me start sharing. Is there any other question or something we could help you? So I think no question remains. See you soon tomorrow. Great morning, evening, night. I would end the call.